Now see, this is OSC question number 10th, functions topic. We have to find the range of this function fx equals to square root of greatest integer of sin 2x minus greatest integer of cos 2x. And this is the approach we will follow here. X goes to this function first, greatest integer of sin 2x minus greatest integer of cos 2x, and then it goes in square root. And to find the values we will get out of this when we replace x belongs to r here. So we need to note down first that we need not worry about x belongs to r. We need to find the domain of this function, the whole function. Domain is when sin 2 greatest integer of sin 2x minus greatest integer of cos 2x is greater than equal to 0, because we cannot have negative number inside the square root. Means where greatest integer of sin 2x greater than equal to greatest integer of cos 2x. Now once we have these values, that is domain. For every value in domain we can find the corresponding value of y, which will be the outcome of this, and then we'll take square root to get the range, the values y can take for this complete function. We draw graph of sin 2x graph, period is pi, so one complete cycle will take pi interval to complete. And then we draw horizontal lines, mark points of intersection between the graph and the horizontal lines. Between two consecutive points of intersection we flip graph below. So this red graph is the graph of greatest integer of sin 2x. Now greatest integer of cos 2x, we draw graph of cos 2x. Graph of cos 2x is like this. Right, and again we draw horizontal lines already plotted between two mark points of intersection. This draw with blue, this point of intersection with horizontal line, this is the point of intersection with horizontal line, this is the point of intersection with horizontal line. Right, and between two horizontal lines we flip the graph below. Right, now you can see we have the blue graph and then we have the red graph. From left to right we start with the and we have to subtract, we have to see domain of greatest integer of sin 2x greater than this. So it means we have to see subtract greatest integer of cos 2x from sin 2x, and we have to see it should be 0 or more than 0. So you can see so when we separate red from blue, we are getting -1 from this side, 0. So this part is in domain, right? X not x but starting from not 0 but after 0, and in this case the difference is 0. So output of this will be 0 and square root of 0 is 0, so we get 0 as outcome. When we go here, sin 2x is 1 and greatest integer of sin 2x is 1 and greatest integer of cos 2x 0, so difference is 1, right? So this point is in domain because difference is 1, and so this difference is 1 means we'll get 1 out here. So again square root of 1 is 1, we'll get 1 out here, right? So if you go further, red minus blue, here we have again 1, and 1 we have already taken. So right, and again red minus blue is 0, we have already taken it. Red minus blue is -1 here, you can see the red section and the blue section, last part of the graph. Red minus blue is negative, and that's not part of the domain. There is no need to write domain as we don't have to comment of the domain, right? So finally we are getting only two values by taking difference of greatest integer of sin 2x and greatest integer of cos 2x, 0 and 1. So range, the values y can take range is 0 and 1.